Welcome to High Speed Serial Links by Dr. G.S. Javed. In today's class, we will learn about how to reduce the impact of attenuation in a channel. A quick update of brief of what we had last class. So here is a frequency response of the channel and what is the identified attenuation at your desired frequency. So the red region showcases the desired frequency of operation or the range of frequency of operation, and the blue line indicates what is the attenuation at the desired frequency by the channel. So how do you reduce the impact? The way to reduce the impact is going back to what is the environment around the channel. So what is around the channel? Around the channel you have the TX and RX. Now with the signaling to try and reduce the activity at the high frequency, you can first try make changes at TX side to compensate. So here you will be doing compensation at the TX side. Now what will happen at the RX side? RX side also you will do compensation and you will do a lot of signal recovery. Right? So you will do changes at the RX side. The common term that is used for this compensation here is called equalization. So what is the role of equalization? Equalization does something like it adds a behavior as something similar like this, right? Such that the output, what is this? This is like high pass action where you are emphasizing the high frequency components and not emphasizing the low frequency component, to ensure that after the recovery in the RX side, your signal transfer function effectively becomes like a flat line. There is no attenuation. So this is the aim, that the final signal has to look like this in your frequency of operation. So this is the recovery state in the frequency range of your interest. So you do equalization. Now what are the names of equalization that you do? First thing is you do something called pre-equalization or pre-distortion at the TX. So here it is called pre-equalization. At the transmit level, and at the receiver you have got multiple, depending upon how much is the attenuation, multiple things. First thing is you will have a amplifier or something called a variable gain amplifier to vary the gain depending upon where it is situated. In certain cases you will have something called a continuous time linear equalization. What does that is? It tries to recover the work. So what does it do, or what is continuous time equalization? This particular graph will now change to something like a behavior where it is giving flat for the frequencies lower than interest and a small bump above and then below. So typically this increase is be about 4 to 6 dB of gain is what you will get. So if this gain is G1 in dB, at this point, this will be G1 plus 4 to 6 dB. So this is called a continuous time linear equalization transfer function. Right? You try to boost it by 6 dB. 6 dB means you are trying to double the frequency, double the amplitude. For example, if you get say 50 millivolt input here, you are trying to improve at this frequency to be 100 millivolt as an example. So you are going to double the amplitude. After CTLE, you will get something called a decision feedback equalizer or DFE. Now what is DFE? DFE operates in the region beyond here. Whatever attenuation is found here, this would be the region where DFE will come into place. For DFE to come into place, and what extent the DFE have to play, you need two inputs for that. First is, what is the impulse transfer function of the channel. Second, what is the energy spread observed? Energy spread observed between adjacent bits. This is called inter-symbol interference. Let us learn more about these 2 points where DFE will play a role in the next lecture.